Welcome back, everyone. I am going to use the latest, greatest LLM news. OpenAI, who makes ChatGPT, has released 2 open-sourced LLMs, meaning that you can download them. You don't need the internet, and it behaves somewhat like the paid version, but this, you can run it locally on your machine. So if you want more information on LLMs, please watch my Can Chatbots Do Math, and I explain a little bit there more. But for those who have something like LM Studio installed on their machine, try the 20 billion parameter version of this free software that OpenAI, or the LLM that they provided. What I want to do is I want to evaluate the functions that I did in my previous video and see if the 20 billion parameter can evaluate the functions without really using any tools, no internet, and definitely not creating some Python script and running it in the background. Okay, so I've selected the OpenAI GPT OSS 20 billion parameters. Now I can't run the 120 billion. I only have 48 gigs on my Mac here. But here, let's say evaluate. Let's say f of x, right, which is equal to 3x plus 4. This is a linear function. When x equals -2, 0, and 1. Watch my video on me doing it by hand. I'm gonna have OpenAI's OSS do it for me with no internet, just locally. Show the steps on solving this problem, or show the steps on evaluating this function. Okay, let's do it. 29 seconds to think about it. So it's a linear function. It knows that it is. It's going to pop in -2. And let's look at it. It's going to pop in -2 where x is. 3 times -2 is -6. And then going to add to 4. It's -2, just like I did in the video. You pop in 0. It's going to give you 4. Wow. Pop in 1. That's going to be 3. You add to 4. Gives you 7. And here's a summary of the table. Very nice, very nice. Here, input token count 0. Context is 14.9% full. The context window. Okay. I'm pretty sure we can do more. I would recommend probably maybe do a new page, a new content window. But let's keep going here. Let's see if it does it. Now evaluate f of x equals x. You need the caret key, and 2 plus 2x minus 3. And you can always put space there. When x is equal to -1, 0, 2. Show all steps when evaluating. All right, let's see what it does. Took no time and thought. Okay. Now this one, that's interesting. It's doing it differently. Here's a step. Oh, because I said step, didn't I? And the other one, did I say step? Show steps. Yeah, I did. Different. So it says it's a quadratic expression. That's right. So You pop in -1 squared. 2 times -1 is -3. -1 squared is 1. 2 times -1 is -2. And then when you evaluate it all, -4, just like I did in the video. Same thing here. You pop in 0, substitute 0 for x, square the term, multiply by 2, add all the terms, -3, yes. And then same thing here, evaluate for 2, that's going to be 4, 4, and then subtract 3, gives you 5. Wow. And here's a summary of the results. That is wonderful. And those are the same answers that I got. All right, last one, right? Evaluate the f of x equals, and so we're going to put parentheses for the numerator, if you remember the video. X squared, take away 1, we're going to close, so that's on the numerator, divide. Then we're going to put parentheses, because I can't do square roots here. I guess I could say square root, put parentheses, right? 4x minus 2. I think it's smart enough to know this. I don't think I need to put parentheses where it says where the s starts and the end of this. I don't think so. Let's see how smart it is. So I rewrote it. It didn't say what type of function this is. This is a rational function. Ooh, it's doing a lot of things, isn't it? Interesting. Okay. Okay. I was going too fast, and it gives you the domain and some other easy steps. Okay, the content window is 45%. It should work. What I should have done, totally forgot. When x equals 3 over 4 and 3, show me the steps to evaluate. Okay. Function, that looks correct. So it's taking 3 over 4. It's going to square it. And then it's going to add 3 over 4 on the bottom. And the answer is -17 over 16. We'll look at it right now. So over here, we're going to put 3 over 4 on the top. You're going to square it, subtract 1, -7 over 16, just like in my videos. Put 3 over 4 on the denominator. Multiply 4 times 3 over 4 gives you 3. Subtract 2 gives you square root of 1. And thus -7 over 16. You pop in 3 for the equation. It gives you 8 on the top. You pop in 3 on the bottom. It gives you square root of 10. 8 square root of 10. So you have to rationalize. So you multiply by square root of 10. The only thing I didn't do, and I realized this, I didn't reduce. 8 square root of 10 over 10, I did not reduce on mine. So this is even better. 4 square root of 10 over 5. Rationalizing is important. Now, what happened there? It's giving me the, let's see, I believe, I don't know what happened there. I just wanted to copy this. Why do we, I believe it's rationalize the denominator. Why do we rationalize the denominator? Let's see what it tells me. Standard form. In most textbooks, the examples are preferred. The way to write a number with an integer and a denominator, not a square root. ease of comparison and addition. If we want to add, subtract, comparison, or simplify two fractions, having both denominators free of radicals make algebra clear. Oh, okay. Avoid shored-in denominators. Some context, engineering calculations, computer programming, treat shrubs in a denominator as awkward. What is this? Oh, look at that. I did that again. Can you click on this? No. Can I type something and maybe it goes back to what it was? Nope. I don't want to say escape. Can I say escape? Yes. Okay. I'm learning, just like you. What is SURDS? The surprising irrational roots. Okay. Must be an engineering thing. Simplifying further manipulation. When differentiating, integrating, or manipulating algebra expressions, a rationalized denominator often leads to a simpler intermediate step. Okay. All right. So the point was to take some of the functions and try to find out if evaluating the functions in this particular LLM, which is, again, no internet connected to it, it's running locally on my machine, would be able to answer the questions. And sure enough, these particular answers it can. That's amazing. I think is something that you might want to consider. All of this is not to cheat. It's not to do your homework. What this is more of a checking for understanding. You do the work like I did, and then you want to see if your understanding is correct. This is not perfect yet. The paid version might be a little bit better. But we're getting to a point within less than 24 months, an exciting ability to do math with LLMs, even though LLMs are not built for math. Okay? But they're doing something amazing. And this is OpenAI's version of an open source LLM.